Alright, hello again everyone. So today we're going to first go over page 27, the beginning of task 9.5 that you worked on yesterday. Then we're going to go ahead and finish task 9.5 together, completing the rest of the notes, introducing a new idea. So starting here on page 27, you worked on this yesterday. You looked at a table, scatter plot, and line of fit that showed the relationship between the balancing of pieces of spaghetti and the number of pennies. What we ended up looking at in the problems below, starting with number 1, was how we could use that equation they gave us up top to make some predictions. So when they wanted to know how many pennies it would take with 2 pieces of spaghetti, we identified that the pieces of spaghetti is an x value. So right away I know x is 2. I go back to the equation they gave us at the beginning, using that again right here, and then I just substitute that x is 2 into the problem. After that, I can use a calculator to evaluate and get a y answer. I know my y answer is the number of pennies, and that's y is 29.24 pennies. Now, that's what our line predicted would happen. But back in the table, we have some actual information that shows us when there were 2 pieces of spaghetti, it actually went with 40 pennies. And we see that point right there, 2, 40. You can see our line was down here at 29.24. So we also wanted to say, how did the value we predicted with our equation compare to the actual results? Well, if it was actually 2, 40, but we predicted 29.24, I can say our prediction is lower than the actual value, because our prediction 29.24 was lower than what really happened, 40. So then we're going to see similarly in number 2. So this time we've got same idea, this time x is 7. So we put x is 7 into the equation. We get a prediction of 138.64 pennies. We go back to the table. We see that when it was 7 pieces of spaghetti, it was actually 123 pennies. So now this time our prediction 138 is actually higher than what happened, 123. And we can see that back here in the problem. When x is 7, this time you can see our prediction way up here at 138 and what actually happened way down here at 123. So our prediction was higher than what actually happened. Our prediction is higher than the actual value. So last one, when you check x is 4, well this time you end up with y equals 73 pennies, and in fact that is exactly what was shown on the graph and in the table, 4, 73. So this time we can conclude that our prediction was accurate. Our prediction was equal to the actual value. So that's a review of page 27 from yesterday. So now moving ahead, we're all working together here on some new notes in task 9.5. Starting up top, it right away introduces a new idea. So we just saw on page 27 that when we use a line of fit to make predictions, we can then look to see how close our prediction was to what actually happened. That relationship is called a residual. And that is the difference between the actual value, so what actually happened in our table, and the predicted value. And that's what did our equation predict would happen. So we do that by finding actual minus predicted. So if the predicted value is lower than the actual value, we predicted something too low, we say we underpredicted. Our prediction was too low. Well, in that case, if our prediction was too low, the actual value was bigger. So actual minus predicted, a bigger value minus a lower prediction, you're going to get a positive residual. And then likewise, overpredict. Well, if your predicted value is higher than the actual value, your prediction was too big. Well, if the prediction is too big, the actual value was too small. So the smaller number minus that bigger prediction is going to give you a negative residual. So go ahead, take a moment and work on the table below. You've got a table showing the number of pieces of spaghetti, the number of pennies, what actually happened in the table, and what was predicted using the line of fit. So take a moment, go ahead and do actual minus predicted to come up with that list of residuals. Okay, you can pause the video if you want to work on it. If you're ready, go ahead and take a look and check your answers here. So I went right down the list and I did actual minus predicted every time. So there were actually 16 pennies, but we predicted there would be 7. 16 minus 7, that's a residual of 9. And that was an under prediction. We predicted something too low, so we got a positive residual. Actual minus predicted. You can go right down the list there and check the rest of your answers. Residuals of 11, -4, 0, 0. Look what that meant. We had the number of pennies that really happened and the number of pennies predicted were the same. Residual 0. Another residual of 0, then -22, -15, 10, -12, and 27. So now below there, we're going to create our first residual plot together. To do this, we use the original x value. X is 1, but we're not going to use the actual y value. We're not going to use the predicted y value. We're going to use their residual. That when we did actual minus predicted, we got a residual of 9. Remember, that means our prediction was too small. We under predicted. The actual value was bigger. So that residual of 9, and here on that residual plot at the bottom, you can see I went over to where x is 1, and then up to where y is 9. And I did this again and again with 2, 11, and I went over to where x is 2, and up to where y is 11. Go ahead and check the rest of your points to see that you have a point at 3, -4, 5, 0, sorry, that's 4, 0, 5, 0, then 6, -22, 7, -15, 8, 10, 9, -12, and 10, 27. And look at how that compares with the original graph, where the line of best fit went through the scatter plot. And for instance, when x is 1, our residual point was positive. It was 9. And look in here how the actual value was bigger than the line of prediction. So every time we get these positive residuals, like 2, 11, that says that when x was 2, the actual value was again bigger than the line. So above the line matches with above the x-axis. And then you can see one like when x is 3, how the actual point was below the line. So we got a negative residual, and there's our residual plot below the x-axis. And then finally check at 4 and 5, that when it was right on the line, the difference was 0, then we are right on the x-axis. You could almost think of this x-axis is like our line of fit. And any point above the x-axis here was above the line of fit here. Any point below the x-axis down here was below the line of fit over here. And if you get a point right on the x-axis, then you actually had points that were right on the line of best fit. So that's what a residual plot looks like and what a residual plot tells us. So moving over to the top of page 29, looking at our data, well, a residual plot can help tell us whether a linear regression was the best fit for our data. When you study a residual plot, you're studying whether that line of best fit was actually a good fit. Things to watch out for. You'll know that your residual plot tells you have a good line of fit if the points are scattered above and below the x-axis. This would mean that some of the predictions were too low, some of them were too high. Then you also don't want to see a pattern in the points on your residual, and this tells you they were scattered randomly, that there wasn't a whole bunch of points above at first, and then a whole bunch of points below later. But instead, one was too high, and later one was too low. And later on, one was too high, and later on, a different one was too low. So go ahead again, pause the video, take a moment to take a look at the next 3 residual plots right beneath there, 1, 2, and 3. Decide based on these descriptions whether you think they are good residual plots. Do they tell us we have a good line of fit? Or do they show us a bad residual plot and tell us that we had a bad line of fit? Again, go ahead and pause the video, take a look at all 3 of them. All right, and when you're ready, go ahead and take a look with me here and check your 3 answers. So I found number 1 was a good residual. which tells me that this represented something that was a good line of best fit. We have points scattered above the x-axis and others scattered below. And there's no pattern. It goes up and down and kind of all over the place. As opposed to number 2, this was a bad residual. Tells me it was based on a bad line of fit, and the reason was there's a pattern. At first, our predictions were too low. Then later, our predictions were too high. And later, again, our predictions were too low, but it happened in a patterned way instead of a random way like this one. And finally, number 3, also a bad residual, also tells us we had a bad line of fit. This time, it's too many points were above the x-axis. So that's too many of the actual values were up here, meaning our line of fit was under-predicting most of them. Actual values were too high, we were under-predicting most of them. So that's, again, 1 was a good residual, 2 and 3 both bad residual plots. So last bit down here. The value of a residual gives us information about the accuracy of our prediction. So, for example, in number 1, when they ask us about 2, 1.5 on the residual plot, well, the x value is 2. And remember from before with the pieces of spaghetti, that stays the same. So this is still, the original x was 2, whatever that represented this time, pieces of spaghetti or something different. But what the y value now tells us, that 1.5, is that when we did actual minus predicted, we got an answer of 1.5. So that's the actual point was 1.5 higher than the prediction. Remember, you can think of the x-axis as like the line of fit, and this would be the actual point on the scatter plot was 1.5 higher than the line of best fit, higher than our prediction. So similarly in number 2, 6, negative 1.8, again it's when x was 6, that original x value was 6, but the actual point was 1.8 lower than the prediction. The actual point was lower than the line of best fit. And finally, last one here is number 3, and it's 7, 0. So that tells us that when x was 7, there's that original x value of 7, but if we did actual minus predicted and got a residual of 0, that tells us they were the same thing. So there you can think again, the x-axis is like the line of fit, and if there's a point on the x-axis, that's a point that was actually on the line of best fit, telling us that our prediction and our actual value were the same as each other. So that's it for today. If you could just take a picture of pages 28 and 29, show me that you completed these notes, upload them to our Google Classroom. That's all for today. Appreciate it. Thank you, everyone.